Well, how are you doing? Okay, this is going to be a very quick demonstration. Um, this is going to be titled The Sun Proves It's Flat. Okay, so in my last video, I showed the demonstration of when the sun that moves above us, right, it moves along at a constant altitude above the surface of Earth. So that's the sky, this is the Earth. Now, we don't view it doing that because we have perspective. But we view it doing is when it moves, right, we view this happening, right? So if the sun is getting higher, coming to our solar noon, we view this happening, right? So it appears to be getting higher in the sky. If it's going towards the evening time, we view this happening. It appears to be getting lower in the sky. So that's how we can take angular measurements between the surface of Earth and the Sun, because of its apparent perspective position. So it's angular perspective position. That's what we view. That's what we see. Okay, so the Sun is moving at a constant altitude along like a train track, although it's not going straight all the time because it's obviously moving around us. But from what it appears to be doing, but it's holding a constant altitude. That's the point, and it's changing its position, its angular position from the observer, which would be down here. The observer sees this happening. All right, that's what the observer sees. It getting closer to the horizon in the evening, or it's getting closer to solar noon in the at 12 o'clock in the day. All right, that's what they're seeing. Okay, so this is the perspective view that we see, right? And this is what's actually happening, right? Now, I made this from the observer 27 miles high. Now, I kind of held this back a while, but I'm just going to throw it out there now. And I've thought about this a lot more than if anyone is in the comments wanting to attack me. I have a lot more in the arsenal than what I'm putting out in this demonstration. Okay, so if that's 27 miles high, if the sun is 27 miles high, right? Let's just say, I don't know if it is. I can't claim it is because I don't know. But if it's 27 miles high, right? Then when we move it along the track here and we move it out to way out, make it smaller. You have to bear with me now while I'm doing this. Way out and way out to 6,214 miles, or just 210. So if we move it all the way out as far as it can go, right? It's about it there now, right? Holding the same altitude above the surface of Earth, treating the Earth and the sky as parallels, we have an angle of naught, that's 0.24, right? So if the sun is 27 miles high, right, let's just say above the surface of Earth. Now it supposedly changes its apparent or its height above the surface of Earth throughout the year. But let's just say it is 27 miles, right, high, right? Now, whether it does change its altitude above the surface of Earth, I don't know, right? That's just the way it was described. Could be just purely perspective. But if it was 27 miles above the surface of Earth, then it could travel 6,210 or 14 miles, which is equivalent to 5,400 nautical miles, which is the maximum that you can use a sextant with because it's 90 degrees. Then it will have an angular size of 0.24 degrees. That's what you will see, 0.24 degrees. Now, how much you'll see, I don't know, because you'll have a lot of stuff going on. As I said, I have a lot more in my arsenal than I'm letting on here. But that's if it was, right? Now, let's just say it's a little bit lower, right? But if it was 27 miles high, then it would have an angle at 5,400 nautical miles away from the observer. It would have an angle of naught. That's 0.24 degrees. Now, let's just say it's not at 27. Let's just say it's at 18, right? So make it small enough so I can get to it. Let me finish this demonstration eventually. So back this down to 18. So I have to there. Make it all small again. Almost done. Almost there. Move as fast as the program can move. And its angular size, if it's 18 miles above the surface of Earth, its angular size is 0.16 degrees. 0.16 degrees. So I'll move it so you can see it now. 0.16 degrees. So if it's only 18 miles above the surface of Earth, it can hold a constant altitude of 18 miles, travel 5,400 nautical miles or 6,214 statute miles, and it will have an angular size of, once again, 0.16 degrees. So at 27 miles high, it will have an angular, not an angular size, but an angular position at 5,400 nautical miles away of 0.24 degrees. If it's 18 miles high, then at 5,400 nautical miles away, it will have an angular position of 0.16. I don't know. I don't know what height it's at. I can't claim it's at any of those heights. Just putting this out. But I have a lot more talk on into this than I'm letting on. And there's more information I have that I haven't said anything about. So there's no doubt for me that sun proves it's flat. That's that.